Hi there, this is Andy from G&A Numerical, and this video will show the solutions to the calculator section of QTS Numeracy Practice Test 1 offered by the Department for Education. Solutions to the other practice tests can be found for free on our website at qtsmathstest.com. Now, unlike the mental arithmetic section, you actually get to decide when to move on to the next question, using the back and next arrow buttons at the top there. On average, you've just about got 2¼ minutes for each question, but some of them could be done an awful lot quicker than this, which will give you extra time for some of the tougher questions. Don't get bogged down with any one particular question. If you feel that quite a bit of time is passing by, flag the question with this button up here and move on to the next one. You can always come back to it later. And remember, you don't have to get all the questions correct. We're just aiming for the pass mark, which at the moment is 18 out of 28. So, okay, question number 1. I won't be reading all of these out, but I'll read the first one. So it says a maths teacher uses something called a box and whisker diagram to monitor the performance of the class in a series of tests. The box and whisker diagram shows the performance of the class in 4 successive tests. Okay, so our job is to click on the label for the test in which 3/4 of the class achieved 55% or more. So before we can answer the question, we need to talk a little bit about what is a box plot or a box and whisker plot. Essentially, it's a summary diagram that gives you 5 pieces of information. So if we take test 4 as an example then, so what it gives you is tells you the maximum, that's the upper whisker. It tells you about the minimum score, which is the lower whisker. The white line near the middle is called the median, which sounds a bit like medium, and it just means it's the middle value. So if you ordered everybody's score from smallest to biggest, that would be the score that's exactly in the middle. So the median splits the data into halves, so 50% of the values will be on the line or above, and the other 50% will be on the line or below. That only leaves the 2 quartiles left over, so this one will be the upper quartile, this one is the lower quartile. So this splits the data into halves again, so that you've actually got 4 quarters, such that between the upper quartile and the maximum mark, that's the top 25% of the class. The next 25% of the class are from the top of the box to the median, the next 25% from the median line to the lower quartile, and the worst performing 25% of the class are from the lower quartile to the very bottom there. So how can we use that information to answer this question? Well, let's look at the target they were interested in. We were interested in which test did 3/4 of the class achieve 55% or more. So the key information is in telling us is about the 3/4 of the class. So what we actually want is we're interested in the lower quartile and above, because that represents 3/4 or 75% of the class. So we need to have a look at 55%, see which one of these equals 55%, and it's in test 4 there. Okay, so what we've got is we've got 25% of them are here, the next 25% there, another 25% there. That is 3/4 of the class, and they achieved 55% or more. So our answer is test 4. Question 2 starts off with the same preamble at the top. We've got the same question and the same graph, and we can tell that because of these little linking rings here. So we've got actually 3 rings, so that means the first 3 questions on test 1 have got the same data. They'll just ask you a different question each time. So this time they're asking us, the teacher expects the trend of improvement in the median mark to continue into a 5th test. What median percentage mark would they expect if that happened? So we've got a multiple choice. One of these will be correct. And this one's pretty easy. The median is the white line, and we just have to spot what's happening each time. So it's going up by one of these little units, okay? And each one of these is worth 2. So there we're on 60, 62, so 64 must be the answer. Okay, so nothing too difficult there. It wasn't anything about nth term of a series. We're looking for quite simple patterns with these questions. So question 3, once again the same data, the same preamble, except this time we have to answer 3 separate questions and we have to get them all correct in order to get the 1 mark that's available. Which sounds a bit of a swizz, but they are just true or false, so we might even get lucky and guess if we have to. But let's not guess, let's have a look. So test 1, does it have the smallest range of marks? Yes or no? So let's think, what does the range mean? Well, the range in maths and statistics means the biggest take away the smallest mark. Okay. Now test 1, compare that with test 2. We don't even have to work out the difference between the highest and the smallest for each one, because visually we can see that test 1 definitely has a smaller range than test 2. Likewise for test 3. Gets a bit trickier when we're comparing test 1 against test 4. They look quite similar, so we have to have a closer look at it. So for test 1, the maximum was, 72, and the minimum was 44. And for test 4, the maximum was 75. And the minimum was 46. So the differences between those two are 28 and 29. So test 1 has a slightly smaller range. So we didn't have to work these ones out manually. We can use the calculator. We could have avoided even working out all of these here just by looking visually. So what we could have done was to say, okay, the minimum for test 4 is one of these little subunits or 2 marks above, higher than for test 1. We could imagine shifting all of this down so that it matches and then see where the maximum is. So if we did that, this one would still be, I can't draw straight, this one would still be half a unit higher. So that would also tell us that test 1 has a smaller range. But either way, we still know that this is a true statement. For part 2, the highest mark was achieved in test 2. Is that true or false? So this one's dead simple. We're just looking for all of the maximum marks. And in test 2, it was higher than in any other test. So that is a true statement. Finally, in test 4, the lowest mark was 44%. Is that true or false? So here's the lowest mark. We've got 40, 42, 44, 46 is the correct answer there. So that is a false statement. So in question 4, we have to work out how much money was raised for charity. It's quite wordy, but in this type of question, break it down into the income and the costs. So let's do the income first. So the income was 250 tickets at 2 nights, so that's 500 tickets, and they cost £1.50 each. So that is £750. We could do that on the calculator, or good practice for the mental math section, we could say, well, if it was £1 a ticket, it would be £500, and if it was 50p a ticket, it would be half that amount at £250. So £1.50 has to be 500 plus 250, which is £750. They also sold cans of drink, so there were 500 of them, and they sold all of them at 40p each. So here we can also do this in our heads, so we can think, well, 5 times 4 is 20, and we have 1, 2, 3 zeros to add on. 20,000 pence, well, to convert pence to pounds we divide by 100, so we get rid of 2 of them, that's £200. But if you don't like that, you can just do it on the calculator. 500 times 0.4 pounds will get you £200. So the total income was £950. Now for the costs, and the costs are all in this table down here. So we had 500 cans of drink at 30p. So 5 times 3 is 15, and we have 1, 2, 3 zeros To convert to pounds, we get rid of 2 of the zeros, so that's £150. Ticket printing was 10p a ticket, and we already know there were 500 of them. So that has to be basically this number divided by 3, because it's 3 times lower. So that's £50 for the printing of the tickets. And we've got these fixed costs at 50 and 60, so added together that's 110. So the costs add up to 150, 200, 310 pounds. Now we're ready to give the answer. So how much was raised for charity was the income take away the cost. So 950 take away 310 is 640, and luckily for us that is one of our answers there, so that's our answer. Question number 5 is one of those very wordy questions, as you can see from the amount of text on the screen. This question is essentially a speed, distance, time question, so we need to be very familiar with those rules. So there's a formula that says speed equals distance divided by time. Now I know a lot of people don't like rearranging equations, so I'll write this slightly differently. So we've got speed, again distance, and then time, and I'll write it within a triangle. Okay, so quite similar to the above. We'll fill in what we know. So we know from the question the distance was 9 kilometers, so I'll fill that in, 9. And we know that the expected speed they were going to walk at was 4 kilometers an hour, so I'll fill that in. The time is what we don't know. We still don't know how long it's going to take them to walk. So the rule here says, okay, if you want to know the time, pretend it's not there, cover it up, so we'll score it out. The time was 9 divided by 4 equals 2.25 hours. So that's not 2 hours and 25 minutes, because remember, quarter of an hour is actually 15 minutes. So that's 2 hours and 15 minutes for the walk-in. We've also got the resting periods, and there were 2 of those at 20 minutes each, so we'll add that on. So the total amount of time elapsed for resting and walking combined is 2 hours and 55 minutes. That's the hardest bit of the question done. If they're going to reach their destination by 3 o'clock, so let's imagine they reached at exactly 3 o'clock, we're going to subtract 3 hours and then add on 5 minutes, because it didn't take them quite 3 hours. So 1500 hours, 1400 hours, 1300 hours, 1200 hours, add 5 minutes, so the time they should leave is 12:05. Question 6 is one of those lovely quick graph questions. So what proportion of the class can speak 4 languages? Give your answer as a decimal to 1 decimal place. So we can bring the calculator to help us with this one. So how many pupils can speak 4 languages? Well, 4 is with the yellow shading there. So there's 3 of them, and it's out of the 29 pupils. So we've got the calculator. I'm going to use my keyboard because it's a lot quicker. So I just type 3 and a / to make the divide symbol appear here. Divide by 29 and press return on the keyboard to get 0.1034. But the questioner only wanted it to 1 decimal place, so it's 0.1. In question 7, we've got two-way tables, and it's a true or false statements type of question. So we take the first one. True or false, half of the pupils taking geography achieved B or C in maths. So with this type of question, we first have to work out how many pupils took geography. Here's geography, and there's A or A star in geography. So this one here is a total of 13 students getting an A or A star in geography. The number that got a B or C in geography was a total of 38, and so on. So the grand total of pupils doing geography was 98 pupils. Now the second part of the question, which is interested in grade B or C in maths. So here's the label for GCSE maths. There's the grade B or C, and that is a total of 49 pupils. So 49 out of a total of 98 is a half, so that is a true statement. Let's look at statement number 2. More than 3/4 of the pupils taking history achieved a grade E or above in history. So this time we're interested in the right table because that's got the history information. So as before, we need to know how many pupils studied history. So that is a total of 52 pupils. Three-quarters of 52 equals 39. So if more than 39 pupils got an E or above in history, then that would be a true statement as well. So let's have a look at that. So the history information is once again here. So you can see that 5 pupils got an A or A star in history. Don't worry about these numbers, that's what they got in maths. We're just interested in the history. So B or C in history is 22 pupils, and a D or E is 14, and that's what the question's interested in here, E or above or E or better. So we've got 14 and 22 and 5 to add together, which adds up to 41, and that is more than 39, so this is also a true statement. For the final statement, less than 10% of the pupils taking geography achieved a grade A or A star in geography. So let's have a look at that. So a total of 13 pupils got an A or A star in geography out of 98. So here we don't even need the calculator because 10% of 98 would be 9.8 and 13 is clearly above that. So this is not a true statement, this is false. So question 8 has another nasty looking table, but let's read the question and see what we need to read from the table. So we have to click on the letter for pupils who showed an improvement of more than 6 months in the difference between their actual age and the reading age over the period March to June. So okay, there's March and there's June, actual and reading ages. We don't actually use that information at all. We're interested in the difference, and they have already been worked out for us for both of those time periods. So if we take them one at a time, so the difference for pupil A was a +6 difference, and he improved to a +13 difference. So that's an improvement of 7 months. So that one is more than 6 months, and we'd say, yep, that meets the criteria, and he improved by more than 6 months. We have to go through this same process for all of the remaining pupils, only clicking on the letters where they had more than a 6-month difference. So if we have a look at the next one, went from +13, which is a bigger number, but it only went up to +17, so that's a 4-month improvement, so that's not good enough. The next one, that one actually got worse, +8 going down to +5, so he certainly didn't improve. The next one is only a 3-month improvement. This next one is a 7-month improvement, as is F, as is G. Pupil H got worse by 2 months, so we're not going to click on him. Pupil I is an improvement, even though it's a negative number. It's an improvement of 6 months, but we're not going to click it because the rule says it had to be more than 6 months, so we're going to leave him alone as well. Pupil J, that's only a 1-month difference, and pupil K, he improved by 10 months, so we'll click him as well. So those are the 5 students who improved by more than 6 months. For question 9, we just have to fill in the blanks, and these are the possible options. So for maths, there's a blank, and we've got a total number of pupils getting certain grade boundaries. So all we need is, let's bring the calculator to help us. The total of 234 minus 76 minus 84 will give us the blank for here. So I'm going to use my keyboard because it's quicker. 234 minus 76 minus 84, press return, is 74. So I drag that into place. So for this one, the English percentage getting A star to D, let's have a look at that. So A star to D is going to be 78 plus 96. So let's do that. 78 plus 96 is 174, and I'm going to divide that by the total of 234. Divided by 234 and I'll times 100 to get it into a percent. So 74.35. We only want it to the nearest whole number, so 74 will be our answer for this one too. So for the final one, it's the same procedure. Let's cancel that on the calculator. We've got 64 plus 98 equals 162 to divide by 234, times once again by 100 to make it a percent, and we've got 69.2, but we'll round that once again to a whole number. 69% is the answer. If you make a mistake in a question like this, you can always drag it back out again and try again, but we didn't make a mistake, so that's our final answer. Question 10 is a cumulative frequency question, and it's a special type of cumulative frequency where you've actually got grade boundaries on the horizontal axis, which does cause confusion, but let's have a look at it. So we need to find out what percentage of pupils was predicted to achieve a C grade and above. The trick of this question is that they've given you grade boundaries and below. So what we actually need to do is to go down from the C grade to a D and below. We look at the blue line for predicted, so D and below was 60% of them. So surely the remainder, which is 40%, did better than a D or below. And better than a D or below is equivalent to a C and above. So we actually needed 100% minus 60%, just leaving the 40% left over. So 40% is our answer. In question 11, we've got a scatter graph, and we've been asked to click on the correct letter for the school which had the same result in both years. So that's 2010 and 2011. The school we're looking for will lie on the line that goes through the diagonal of 00, 1010, 2020, 3030. It just misses school J, so it's not J. Let's see if we can find it. Looks like it goes through G, so I'll click on that for now. It just misses this school, and it's not going to hit school A either. So the answer is school G, and we just click on it to give our answer. Nice and easy, that one. In question 12, it might help to use your mini whiteboard for this question and almost treat it as a mental arithmetic question. So here we've got 3 classes who carried out an experiment. Each class had 28 pupils, and they're going to work in pairs, so there's 14 pairs, okay? And they're going to use 10 cubic centimeters of acid, okay, fine. Each pair repeated the experiment once, okay, fine. What was the minimum number of cubic centimeters of acid the teacher needed? Okay, so we're going to assume there's no wastage. We've got 28 pupils in the class. We're going to half that to get 14 pairs, but we're going to double it again, back up to 28, because each pair repeats the experiment. So we've got 28, and we're going to times that by 3, because there's 3 such classes doing that. So 28 times 3 is 84, and we're going to times that 84 by the amount of liquid that they're going to use, which is times 10. So the total amount needed, assuming no wastage, is 840 cubic centimeters. Question 13 is another drag and drop question, so let's take a look at it. We just have to drag and drop the correct values from here into the table. So here we've got the difference between boys and girls mean maths point scores, okay, and we've got it for 3 time periods or 3 years. So in 2009 they got 1.8, and that's just 24.3 take away 22.5. So if we do the same for the missing year, 2010, we'll even use the calculator to help us out. So we've got 24.8 minus 23.2, and that's 1.6. So that's one of the options. We'll drag it into place. So now we have to work out the mean difference for the 3 years. So the mean is the same as the average. you add up all of these three numbers and divide by 3 because there are three numbers. So let's do that. We have 1.8 plus 1.6 plus 0.2 equals 3.6, and we'll divide that by 3 because there are three numbers, and we get 1.2. So we drag that into place. So those were our answers. I just wanted to point out they've actually made a mistake with this question, which is a bit unfortunate, and we can tell that with their answer to this question here. So their entry for the difference between the boys and the girls, they've put 0.2, and for me it should be minus 0.2. 24.9 minus 25.1, that's a minus 0.2, because that was the order they chose to do it for these first 2 years. Can you see? 24.3 minus 22.5 is a plus 1.8. We copied that in 2010, but in 2011 it should be a negative. So really it should be 1.8 plus 1.6 minus 0.2 and then divided by 3. But that wouldn't give you one of the answers that they gave you. So hopefully a mistake like that won't come up in the real thing, but you never know. Question 14's got a load of numbers here to try and confuse you, but let's break it down. So we've got a trip for 15 pupils, and there was a £2.50 entry fee, and the minibus cost 30p a mile. Okay. Minibus mileometer read 33,896 before the trip and 34,016 after the trip. So they could have just told us how long the distance was, but they wanted to make it difficult. So on the calculator you'd work out the difference between those two, and it turns out to be 120 miles. Each pupil paid £5 to go on the trip. So your question is, what was the difference between the total money charged to the pupils and the total cost of the trip? So it's a money question, so let's split up the costs from the income. So let's do the income first. Each pupil was charged £5 and there were 15 pupils. 15 times 10 would be 150, so half that amount must be 75. And that's the only income was from the amount charged to the pupils, so that's £75. The costs was the fuel and the tickets. So the fuel cost was 120 miles times by 30p a mile, or 0.3 pounds if you like. So you can do it on the calculator if you like, but it's good practice just to try it out here. So we've got 12 times 3 is 36. A 0 here and another 0 here. So that's 3,600 pence. To convert back to pounds, we're dividing by 100, so that's £36. And the entry fee to the museum was £2.50 for each pupil, so it has to be half this amount, because here they were charged £5. So half of the 75 is £37.50. So the costs incurred was 36 plus 37.50, which is £73.50. And the income was just £1.50 more than that. So our answer is there was a surplus or an extra of £1.50. Question 15, indicate all the true statements again. Okay, so a strange kind of question, this one. We've got a conversion graph showing predicted A-level grades for chemistry and the corresponding mean GCSE point scores. So we don't have to understand what this graph means, we just have to get enough information from it to answer true or false to the three statements. So what we're going to need to do is to work out the different grades for each of these GCSE point scores. So if we take the first one, pupil F, his score was 6.6. Okay, so we just have to find where 6.6 puts him on the A-level prediction scale. So there's 6.5 and he's just above that. So pupil F will be just in the C category. So he'd be on a C. So we'll do that for the rest of them. So pupil G, 7.8, well he's all the way over here, he's into an A grade. Pupil H, 5.4, well, that's just into an E. Pupil I with a 6.4, that's just below a C grade, so he's on a D. Pupil J on a 6.2, that's also a D. Pupil K, well, 6.4 we've already seen before, that's a D. Pupil L on 4.8, so that's just into an N grade. And pupil M on 5.4, which we've seen up here, that was an E grade. So now we've got all the grades listed, we can easily answer these three questions. So pupils J and K were predicted to achieve the same A-level grade. So there's J, there's K, they were both predicted a D, so that's a true statement. Statement 2. A third of the pupils in the group were predicted to achieve a C grade or above. Well, okay, let's see how many pupils were expected to achieve a C and above. And it's just these first two, so that's 2 out of a total of 8. So 2/8 is 1/4, which is certainly not a third, so that's a false statement. Finally, the mode of the predicted grades was a D. So the mode just means it's the most frequently occurring, and there were 3 D grades, and that occurred more often than any other grade, so that's a true statement. Question 16, the final question. Hope you're still awake. So what we've got here is a bar chart put on its side, a stacked bar chart, and it's true, indicate all the true statements. So statement number 1, the reception year had 2 fewer lessons graded unsatisfactory poor than year 2. Okay, so what we've been given here is percentages, and we have to read up here to know that it's 20 lessons from each of these groups. Okay, so in year 2, 10% of the 20 lessons were graded unsatisfactory or poor. So 10% of 20 is 2 lessons. So 5% of the 20 lessons is only going to be 1 lesson. So the difference between those two is just 1. So that's a false statement, because it's not 2 years, it's only so that's a false statement, because the question said it should have 2 fewer and it only has 1 fewer. Statement number 2. In year 3, 7 lessons were graded as good or very good. So let's look at year 3. Year 3 good or very good is 35% of those 20. So let's bring the calculator out to help us. 35% means 35 divided by 100 times by 20 equals 7. So that's a true statement. 7 lessons were graded as good or very good. Finally, the ratio of good, very good to unsatisfactory poor in year 6 was 5:1. So let's look at year 6. Good, very good was 45. Unsatisfactory poor was only 5. So 45 divided by 5 is 9. So that would be a 9:1 ratio. So that's also a false statement. Thanks for watching, and if the video helped you, please let me know. I'd love to hear about your success stories, and thanks for watching. Bye for now.